All right, let's take a look at the notes for segment, addition, and midpoints. What we're trying to do is just get our basic understanding of things and get some ideas for when we go to solve some problems. So let's take a look here. Get my pen. There we go. First, basic vocab. Segment. You've seen segments before. You know what they look like, but just to be clear, segment looks like that. We don't always draw the dots at the end, but a segment is a part of a line. And with our segment, we name it with its endpoints. And so if that's A and B, we would name it AB with the segment over the top. Or we could say BA. Doesn't matter where you start and where you finish. Now, that is still true even if there are more points named in here. If I had another point C or D or whatever, if I'm talking about the whole thing, it's still segment AB. I don't put more names in there, even if they're drawn. Collinear, take a look at it there. It's kind of telling you what the deal is. Collinear is all about a line. So if points are collinear, they are in the same line. Now here's where it might be a little bit confusing. The line may or may not be drawn. The points could just be on the paper, but if you could draw a line through them, they are still collinear, even if the line doesn't currently exist. Bisect, well, we see the prefix, we know it's going to be 2, and it is something that cuts an object in half. Now, what is this object? Well, it could be a lot of things. For us, it'll be a segment that we're cutting in half. We could also cut an angle in half. We'll see that next week. A lot of things could be bisected, but right now we're looking at segment. And as we talk a little bit more lower on this page, you'll see our common way to say that we're bisecting a segment, which is to talk about the midpoint, which is the point that does cut a segment in half. Next up, how to mark segments congruent. If you have a segment and let's say that that's the midpoint, we want people to know that this piece is congruent to this piece, and the way we do that is simple. We put the same little mark on both of those. So anybody that knows about geometry, when they look at this, they know that that's not just any point, that's the exact center, that's the midpoint, because the two halves are marked the same. Now you could have two completely separate segments and we could still mark them congruent. I'm going to put 2 marks on that one and 2 marks on that one so that people know that those two match up, because I also have a 1 mark already. I don't want to repeat that mark unless I'm trying to say all of the pieces were the same. If I'm just trying to say these two are the same, I should put a unique mark on those two. So that's how we're always going to mark things in our diagram as congruent, and always mark those diagrams. Segment addition postulate. If A, B, and C are collinear points and B is between A and C, then, well, I'm going to go for a picture and I'm going to take a look at this. A, B, and C are collinear and B is between A and C. So I'm going to put A all the way at this end. I'm going to put C all the way at this end. B is between. It doesn't say midpoint, so I'm not putting it at the exact center. I'm just putting it in there somewhere. If they don't tell me midpoint, I don't want to assume it, so I don't draw it looking like that. So what I know from this situation, since they're collinear, they're all on this same segment, I now have 2 little segments that combine to give me a bigger segment. And that's exactly what I'm going to show up here, that AB, the length of that, remember, if there's no segment on the top, we're talking about length. We're adding up, so we're talking about length or numbers. So the distance between A and B, the length of this part, plus the length of this part. would equal the whole thing, AC. So segment addition is literally adding up these segment pieces. Now it's really the segment measurements that we're adding up because that's what we calculate with numbers. Okay? And that can happen anytime you have a point between two others. Again, does not have to be midpoint at all. The pieces still add up to the whole thing, even if it's not a midpoint. Okay, I'm going to clear that and come on down to the rest then. Talk about this. Definition of midpoint. It says the midpoint of a segment divides the segment into two congruent parts, equal lengths. So if M is the midpoint, then, well, I'm going to do another picture here. Segment AB, that endpoint is A, that endpoint is B. This time it says M is the midpoint, so I'm going to put it exactly in the middle as best I can do. And just like before, I'm going to show it by marking things. If it's the midpoint, I know those two are the same. And that's exactly what we're going to say up here, that AM would be the same as MB. When it's a midpoint, I know those two pieces are equal, so I can set them equal to each other and solve. I don't have to add this one plus this one equals the whole thing because I have more information. I know that the pieces are equal. So that's what I do when it's a midpoint. So down here then we have a little information about how to solve segment problems, what you're going to be doing next. First of all, always mark your diagram. If you know things are congruent, put it there. If they said that AM was 2x plus 3, label it. Write a 2x plus 3 here. Put all the information onto that diagram. Then determine if any segments are congruent. If they said midpoint, you know they are. If they flat out said AB is congruent to CD, go ahead and mark it, use it. If you see that, you can set those pieces equal to each other and solve. If not, then it must be more the segment addition thing where you say, oh, this little piece plus this little piece equals this whole big thing. And then you would set that up and solve. So it's going to be one or the other. Either you have equal pieces or you don't, but you can add them up to make an equation. After you solve your equation to find your variable, check back and see what the question's asking. Did it ask for X or did it ask for AB or BC or something where you need to plug it back in? A lot of times people forget that last step and they're almost there, but not quite. And then finally, step number 5 says you can always plug your answer in to see if the pieces are really equal or if they really add up the way they should or whatever's supposed to happen in the problem. And we're going to go through a couple examples in class to look at that.